Hello there, thanks for watching this video. Now I am going to prepare sequence of tutorial for data structure and algorithm. If you want to learn data structure algorithm and you are beginner, or if you are experienced and you are preparing for interviews, this video is for you. And if you want to learn in and out of this data structure algorithm, please be with me and I will teach you, and I will give you such knowledge that you can easily write your own data structure and algorithm. You can write the programs, you can go for the lead code coding programming, you can crack your interview very easily. Now, so before starting our data structure and algorithm, so I will start with very basic our array. And I'm assuming everyone who is learned or who working, definitely they have gone through the array, and either he is using the Java or .NET, C Sharp, Python. Everyone has a array experience. I'm assuming this one, and I know that everyone at least they have. So in this data structure algorithms, we are gonna to cover a very depth actually, and I will give you complete in and out of data structure, and I will make you more comfortable in this area, so you will not feel any issues and any programming related issues. So basically I will cover some theory, and after that I will move to the some practicals. I will do the live programming, and I will show you all these details, how we write the programs, how we calculate the complexity of any scenarios, how you will see this, which program is the better and which program is the not. You can compare that one. You can, after seeing these programs, you can easily identify which program will take this much time and which efficient programs, which optimized code has been written. You can easily identify that one. And meanwhile, while journey of this tutorials or series of videos, I will cover some lead code program also. I will take it, and I will try to take some programs where I can show you the lives, how we can do this, how we can, it's a better approach, and how where you should target that one, where is the best way you can write the program. So don't waste our time, let's start our tutorials, and so that we can focus more on theory and practical. So basically before starting this our array, now I have make one written some things just for this rough idea, so that I can't spend much time in this way, and we can easily focus on our work, and we can more focus on theory and practical simultaneously. Now basically, so generally, right, while we are writing the programs, we have, nowadays we have a good infrastructures, we have a good hardware, and we have a good processor core, where our programs take less time compared to 19th, when we are, someone was the 19th writing the code, their programs timing and the space was taking too much time while that were writing the code. So that time when they are writing the program actually, and they had not that much a good hardware, and they don't have the very good processor and space, I mean say that memory to execute the program. So the program which was written that time 19, and if you execute the same program now in our today's infrastructure, where we are using good hardware, we have clouds we available now, so there the performance will be a completely outstanding actually, you can't compare that one. So nowadays our more focus is towards the time optimizations of your code and performance of your code, how quick response your code is giving to, because nowadays we have a hardware, we have a very good hardware, we have a very good processor, and we have a very good space, we don't have any issues for that in these areas. But the thing is, the time which our program is taking, it should be a very less, it should not take that much time, because no one has the time, no customers, no users wants to wait, right? They don't want to go to the waiting state, they want response within a fraction of second, right? So how we can write a program in such a way that our system or our program should not take to process the data, and in a very efficient time or in quick response, he will process your data and he should return back to you, right? So this is the current demand, everyone wants this should be implemented in your applications. So So before starting this one, so I'm just give little bit brief for here so that we can easily move, and it will make you some little bit picture so that you can just imagine while we are writing these programs and we are learning and doing some practical. So basically in these programs I'm completely using going to use a Java. So I will come use Java for complete data extraction algorithm. So you can see here now we are generally using the BIGO notations, right? So we call it most of the time I will call while I will starting the programming, I will just write the code, I will show you the time complexity space. So basically we are talking about the BIGO notations, right? So BIGO means what I are doing, we are while you are watching this program you can identify the complexity of the program, how much time it will take, and what is the complex, how much complex is this one. So suppose if you are writing any program and it's after visualizations you can see that yeah, this program is efficient, it will time complexity or space or executions will take how much time, right? So now here you can see here I have mentioned here the constant time, right? So constant BIGO one constant means in this constant particular time it will give you the response. Suppose you have a very big chunk of data is coming, it might be coming from the database, it might coming from any REST API, any third party or SOAP API, whatever you're using microservices. Suppose you are getting complete array, okay. The example here you can identify here, suppose you're getting the complete data, that is array you have. Now if you know the index positions, right, you have an index. If you know the index and you want to pick any elements where the location is that, you can easily identify that. Or suppose you have any array that is coming as a like suppose input or output array, right? You know that at 1001 location your data is there. If you pass the values, that will retrieve the data, right? That is a constant time, means in the constant you will get the data. That is called a BIGO. That is a nothing but is a BIGO of 1, right? That is a constant time. If it is algorithm, it will take a O of log 2 base n, right? So that is algorithmic in time. So that I will explain. I will show you in the program. So I am writing the program. Now coming to the point of BIGO of n, that is a linear. So suppose today you are getting the 10 elements from the backend and you are processing, time is taking for 10 elements. Suppose I am assuming is a 5 second. Now suppose if you tomorrow you get a 20, so what will happen, your linearly it's going to be increased. Suppose today is 10, tomorrow is 20, today is taking 5 seconds to process your 10 data. If data will come as a 20, it will take you the 10 seconds tomorrow. Now day after tomorrow, if its data is coming suppose as a 30, so how much time it will take, it will take the 15 seconds. 10 processing your 10 data, it's taking 5 seconds. 20 data, it will be 10 seconds. 30 data, it will be a 15 seconds. So it's a linearly going to be increased as per depends upon your the data. Now another is the log BIGO n log base 2n, that is n log star n, that we will discuss while we are writing the programs. And now that is the last one, that is a nothing but a BIGO of n square 2. So in that case we have a quadratic in this nature. Quadratic in the sense when you have a data, right? Suppose you have a 20 data, but while you are processing you are writing loop in a such a way that it will process as a 40 data. So here suppose if you take the example of that one, suppose you have a two loops, two for loops together. One that is outer, next one is the inner. Both outer and inner will execute. First your outer will take one element and execute the complete inner for loop. Again it will be take the second elements and again execute the complete your inner elements except one element. So what will happen, it's a quadratic will be the nature, means it will take that was the time what the data you have into the square, it will happen. So this is the concept of the BIGO notations. Now apart from that BIGO notations, let's come to the some feature and some behavior of your array, how it will, because array is a basic things we can think, right? But array is a one data section and we can't skip this one, right? So it's a big and we have to play with the array. So array is nothing but it's a continuous block in memory, right? So suppose if you declare array, right? So array what it will do here, let me just make some more pictorial view. Suppose while you declare array, right, like this, so it will occupy this much of area. This is not nothing but is the space area in the memory, right? And in this array you have a number of elements. Suppose you have a more than 10, whatever the elements means, your data elements, nothing but your data, 1 2 3 4 5 6 7, like infinite, I'm assuming. Okay, so what will happen in this case, this is the nothing but continuous space it will occupy in the memory. If I'm assuming this is my memory, if I'm declare any array, so this much piece of code, this much piece of area will be occupied by your array. Okay, so continuous block of memory it will occupy in your array. Now if I will come to that here, now every element occupy the same amount of space in memory. So here example saying, if your this space, suppose this is an integer you have mentioned here, it is occupy the 4 bytes, right? So all the elements what you have declared is your array will take, this will take another 4 bytes, another 4 bytes, another 4 bytes. So every elements on your array will occupy 4 bytes of memory space in the memory, right? So it's a very clear. Now it will be a 4 bytes, suppose, and if this is the block is occupied memory, and every elements of your array will occupy the same bytes of memory in the memory where you have your heap. I mean your array will get, it may be hard disk, it may be a RAM, or it may be heap memory where processing the data, it will occupy this much of area or heap in the space in the memory. Now come to that third point. So suppose here I have mentioned if an array start at memory address X and the size of the each element of the in the array is Y, we can calculate the memory address of the ith elements by using this expression. So what I'm trying to say here, suppose if I'm assuming in, sorry, oh it's looks okay, no, okay, suppose this is my first element, right? Now what I'm assuming, my first elements will occupy the address, the location, either you can say the address or you can say the location, you can say the memory address. It's 12, suppose is a Vocus address, which what I'm just assuming, and this is the locations at 12th positions, it's going to be my first elements will occupy. Now what will happen, my second elements will go at which location, 12 plus I, okay, into 4, okay, so it will be a 16, right? So at the position of 16 my second elements will go, right? My second elements will be go in the 16th position. If you know the address, a location of first element or any location of your elements of an array, you can go till end of the array using that process, right? Using this formula you can identify your address of the location and address where your element will be stored. Suppose if the third elements users will say where it will go to save, it will be the same 12 plus same formula is going to be occupied, right? I, okay, into the 4, okay, equal to, it will be a, it will become a I nothing but 3, right? 1 2 3 12, right? It will be occupied your 20th position. So it will be a 4 into 2, right? It will be 2. It will start from the 0 1 2, right? 4 into 2 8 plus 12, it will be a 20th. So in the 20th location your third elements is going to be occupied. Now if your fourth elements will come, suppose it will be locations 12, if that's the first elements, for it will be 0 1 2 3, this will be 3, okay, into 4 bytes occupied the memory, okay. Now what will, this will be 12 plus 20 24. So your these elements 1 2 3 4, your fourth elements will be the address of the 20th fourth, okay. So this way your array will work and it will occupy the memory, and all the elements of your array will occupy the same space, same bytes of memory space in the memory, okay. Now apart from that, let's start with our program. Now let's move to our IntelliJ. We will not spend much time here and we will do the practical, and I will show you how easy a data section algorithm, so you will enjoy after reading, after going through these videos. Now I will just move to my IntelliJ so that we will start our program. Now I have created one package here, com.codingmania. Now I will going to the create one Java file. Suppose I will mark as a test array. Okay. So this class I am just writing this one. So just for a very simple program to show the array, how will declare the array, how will print, so that because this array we are going to use in our program continuously, and it will be very huge now, and we have to concentrate our all the sortings and all these details what we are going, because as we are I'm planning to show that all this demo like first I will start from sorting, and I will cover all the sort like the bubble sort, assertion sort, selection sort, merge sort, everything I will recursion I will cover. After that I will go for the switch to the list. After then I will come to the stacks, queue, heaps. I will create our own hash tables, and I will write the tree, BST, everything I am gonna to cover in this program. So basically now I will start from the beginning, and I will go to the very depth. And if you will continue with my videos and learning, definitely you will get a lots of things from this video, and it's a very good learning for you. Now let's start with our program. I am going to start my main method. Here I will start very basic programs. I will write int array, I will create it. Now it will be int array. So basically here suppose I am creating array of this size 10. Okay, so you can see here now, just now I shown you, right, when you are writing the programs and you declare this one, so it will occupy same space in the memory, same 10th space in the memory, elements will be occupied in the memory, and on these elements your all the elements is going to be stored. Whatever the elements you will show which location, it's gonna to be stored in the memory. Okay, okay, so memory occupy, I will write this one, so just for reference. No, so what I can do, I will just put the array, okay, at 0th positions will be, suppose I am putting 20th. Okay, now we have a 10 elements, right, so it will be start from the 0 and will go till the 9, right, because it will be starting from the indexer. So I will write 2 3 4 5 6 7 8 9 10. Okay, now it will start from the 0, it will be a 1 2 3 4 5 6 7 8 and 9. So this is a 20th. Okay, now I will mark as a minus 15 and mark 30 50 110 minus 110, or make something different, 140 31 91 71 and 102, right? So you can see here I have a declare one array which will occupy the space and memory in our, this much of memory in our memory where we are going to be stored. It's maybe hard disk where we store it, it's maybe your heap memory, it's maybe your RAM while executing the programs. This much of continuous block of memory is going to be occupied. And if you can see here, these elements I'm just putting the value. Suppose at a position of 0 1 2 3 4 5 6 7 8 9, I am putting these elements so that it's gonna to be store our elements in the particular space. So you might remember, right, just now I have so you suppose I mentioned one bogus memory, right, suppose at the 12th positions it is occupied, so next elements will be at which address is gonna to be stored, right? So what will be the formula for that one? It will be a 12 plus I into 4 bytes. So this will be the location there this elements is going to be stored, and this will be the location, this will address what the address I have mentioned here. It will be the for this particular elements in this particular int array of 1, and I am assuming as a bogus address at the 12th. This is the location where 12th position location in the memory this space where is 20th will be stored will be the 12th. Now what will be the next address for this one? It again will be the 12th plus I into 4. 4 is nothing but the bytes of, sorry, it will be a 4, it's a mistake. it will be a 4 byte of the space they have occupied, right? So how will be the calculations? It will be a your first element, it will be a second element. So this is the 12th address. Address will be 12th. Now what will be the address for this one? It will be a 12 plus 4 equal to 16. So for them it will be a 60th, right? So for them it will be a 60th location. Address location will be a 60th. Or if you calculate this one, you will see here 4 into 2 8 plus 12, it will be a 20th, right? So 20th address, it will be store your elements. Sorry. Okay, so this way it's gonna to store. Now I'm gonna to print this array. So it's okay. I will start from the 0 I less than int array dot length, okay, I plus plus. So I'm not gonna to explain why I've written this array length in array. It should be not method. I'm assuming you know all the at least these things. So I will start from the now onwards, so that it will be easy for me to cover all these topics. Now it will be an int array of putting I, okay. So if you will execute this program, you can see here your all outputs. So it just like our first program. So that next onwards we will start and we will switch to our sorting, okay. So this is our first array programs what we have mentioned. Now all the elements has been display here, you can see in the from the memory. Now let's move to our sorting. So now our main sort, okay, package is there, I have mentioned it. So I will start our bubble sort. Okay, now so what I can do, I will move to again back here our documents. So I will, okay, now it's fine, right? I will start here. So bubble sort. Okay, so one topic I would like to cover before starting the bubble sort, type of sorting, right? So my first points will be here, stable and unstable sort, okay? Stable sort, okay. So what is the difference between stable and unstable sort, right? So before starting bubble sort, I just should give these informations to you so that you are aware of that one. So sortings I have divided into two sorts, that is a stable sort and bubble sort. Now let's assume you are getting some data from the backend like this, okay. T70, like this, okay. And I will write one more time 66 here. Suppose this is a data is coming from the backend. It's maybe your database. Again, I'm trying to see here. It's maybe a front end. It's maybe a backend. It's maybe any third-party API. Right? We're calling. Suppose I have an input as this array, right? Now you can see here. If we are going to sort this one, right? What will happen? It will sort. It, no doubt. It will sort, right? How it will sort? It will first 20 will come, then 21 will, 22 will come, then after then 37 is there. After 37 what you will get? 66. Then you have a 77, 91 and 99, right? 3, 4, 5, 6, 7, 8, 9, 3, 4, 5, 6, 7, 8, 9, 10, 20, 22, 37, 66, 66, 77. Okay, 77 is also 2 time I have written here, so I will just remove 177 from here for time being, because I want to explain something here, so that I will just remove 177. Okay, minus 6. Now what I will do here, this you can see, your 66 is there, right? So if you can see here, 66 is 2 times, right? If I will, let me highlight this one, mark as yellow, and I will mark this one as a blue. Okay? And I will mark this one as a different color, red. Okay, now I can see here, we have a 66 which is a red color, and we have 66 that is a blue color, right? And there is a, this is two duplicates value. Now while you are sorting this value, what will happen, it's going to be sorted, right? So when it will sort it, there is a chances either your, this one will come as a sort first elements, and this one will come as your the second elements, right? The way it has been already in the duplicates, the unsorted elements, now after sorting it's also preserve the same position, 66 and 66. That is called a stable sort. If it is preserve the same positions, we call as a sorted stable sort. But suppose if it will not, if it in case if won't preserve that location, that means we call this one as a unstable sorting. Now here questions will come, what is the difference between 66 will come either this one or first this one, right? It will not visible here, right? But in the case of objects, it will be a big things. It's here, it is not that much bigger, but while you are talking about the objects, it's a big things. Okay, that's why I just explained this one. So while you see such type of questions will come and you are doing, then you make sure that you have some idea. If it is conserve the same positions where before sorting and after the sorting, right? If it is conserve the same, preserve the same positions, that is called a stable sorting. But if it is not, if it is going to be exchange, that is called unstable sorting. Okay, so this was the just short exams things I just want to give you. Now I am going to give you the start with our bubble sort. So in the bubble sort, what we do, right? We have, let me arrange this element so that you can, okay, now here you can see here in the bubble sort what will happen, we have identify one swapping will used, okay, in the bubble sort. So suppose if it is the first and second elements, first I will take this first and second element and I will check it first, I is greater than I plus 1, no, then what will happen, your, this will be your the large elements. Okay, in the longest element or largest element we will put this 22. Now what I will compare, I2 is greater than I1, I plus 1 means this location 21, yes it is greater. Now I will, it will swap, means it will come here, 22 will come here. So I will show you in the how will happen in the first loop, right? When it executed, it will unsorted format, we have declared this one elements. So first it will, we compare I and I plus 1. I will check I is greater than I plus 1. You can say no, I plus 1 is greater. Then I will what I can do, in the longest element I will put I plus 1, that is a 22. After then what I will check I plus 1, that is this element is greater than I plus this element. Okay, yes it is greater. Then I will not do anything, I will check, oh this element is greater than this one, yes this is greater than this one, no this is not greater than this one, this element is 91 is greater, I will push the 91 as the longest element. Now 91 is greater than this element. Yes, 91 is greater than this element. I won't do anything. 99 is greater than this element. 66. Yes, 99 is greater than this element. I won't swap. 99 is greater than 31, 37. Yes, 99 is greater than 37. I won't swap. 99 is greater than 91. Yes, 99 is greater than 91. I won't swap. Yes, 99 is greater than 66. No, 99 is greater than 66. So what will happen in the finally? First, I will write in the first step what will happen. The after that swapping, it will be a 22. Okay, 21. It become a 66. Then 77. Again 66. Again 37. Again 91, and it's become 99 here. Okay. So you can see here in the first step, I'm saying it will be a first step executions. When first loop will execute, it will make your elements like this. Your these elements, which is the largest elements, is going to be shifted in the correct position. That is a sorting position that will come at the end of these elements. Okay, and it will be replaced. So this bubble sort, what we are going to do, we are going to shuffle it. We are going to check, swap it, which one is greater. We have to take the greater one, move to the next. If it is now, we'll compare to the next element. If not, compare to the next element. Like that we are going to execute this one. So when I will write the program for this one, you will very easily identify, okay, this is might be a not, you might not understand here, but when I will write the program, you can easily understand what, how it will work. So I will, let me switch to my IntelliJ now, and we will start our the bubble sort. Now I'm going to start my programs. I will start from the main method. So here, very simple, I will just write the same example what I have written before. Array will declare it. Okay, new, or we can write directly here. We can create this array. 15, 16, 17, 59, 45, 52. Okay. So I have declared this array. We have to go into sort it, right? So what we explain you, right? So what we are going to do, we are going to just swap it, right? You will see this is greater than this, the second elements or not. This is greater than this or not. Like the simple way we have to go and implement it. So simple. So what I will do here, I will write one program here. So, sorry, one methods, so that now if you can see here, if I is equal to j, okay, so I think nothing we need to do here, we simply return it. Okay, if both are same, no useful for us. Now what I can do, I will write one temporary variable. Okay, in this temporary variable I will put array at I. Okay, after that we will put, sorry, with j. Okay. This is simple swapping I'm doing. I'm not doing any fancy things. This is very simple. I will swap this one to element. That's all. Okay. So we can pass this temporary variable. So right now what I can do it here, I will just for loop int
1.
minus minus, okay. So it will execute this way, and after that what we are going to do, we have a formula. If I ith elements, actually if it is greater than this one, then we have to swap it, right? We have to take this bigger one to the last, right? So that's why I have written here as a, you can see here I have a variable name as given last unsorted, last unsorted, sorry, it will be a last unsorted, okay. So this name I have mentioned is the last unsorted, so it will go to the last, right? That's why what we are doing here, we are simply running one loop actually from this top, I mean from the higher to lower, that's the length to -1 it will go. And what I'm going to do, I am going to int I equal to 0 and sorted elements, unsorted, whatever last unsorted index, right? So this is nothing but the size only, nothing is complex, the size is coming here until I plus 1 it will go. So what I am going to check it here, if int I is array of I, means this one particular array, if this is greater than I plus 1, then swap it, or else keep it as it is, if that means this is a greater, right? So I am only using that one. So int I will pass here, okay, I will here I, and I will pass here I plus 1, okay, that's all. So that is enough. I think this is a so simple bubble sort. Many people is scared, right, because of this sorting and detection. Now you can see how small bubble sort is there, right? So this is your the bubble sort. That's all, your implementation is over. Now we are going to check, okay. Once it will done, then what we will do, we are gonna to check our result. Sorry, equal to 0, I less than dot length, dot length, and I plus plus. Now what I will do it here, that's enough. Sort, sorted element, right? So we can see here, no, I, that's all. Now let's execute our program and see the response. Now you can see the response. Response is coming like a -16, 15, 17, 20, 45, 82, and 89. That's all done. We sorted it. So see how simple this data structure. Only swapping, we have a call two for loop. That's all. So you can see here, this is nothing but it's a nature wise. If you can see here, I just explain you little letter here you can. So this is a quadratic in nature, okay, because it's executing two times. So this is quadratic in nature, your bubble sort. And now you can see your data has been filtered, and so simple way we have complete our first data structure, that is sorting, and that is a bubble sort, right? So that's all for this video, and after that I will prepare some other videos and I will keep posting. Thanks for watching this video. If you like it, please like this video or subscribe. That will motivate us. Thank you so much. Bye bye.